we're good to go. So here we are once again, Mr. K. So how are you, Bart?
I'm busy as a blue-ass fly owl, basically. I've been running around the place chasing my tail, trying to be a farmer these days, as well as run my online empire,
Wow.
and do a few other things while I'm at it. So yeah, it's been busy, but yeah, good. How are you?
But yeah, very good, mate. Very good. I've got stranded. I've been trying to talk to you for the last 3 weeks, and I keep rescheduling because I was over halfway to your neck of the woods, as they say in Thailand. But of course, then I got the plane cancelled twice, so it was a bit up in the air trying to get home. But I managed to get home, and so here we are.
Well
But
done.
you're still over in New Zealand, I'm
I,
guessing.
yep, still am.
Yeah. So it's is it the opposite time? It must be morning then where you are.
Yeah, we're just before 9 in the morning on a Tuesday.
Exactly. So it's Tuesday night here. It's almost my bedtime.
Wow.
So with all the we've been doing keto and carnivore now for years, and of course people always, especially new clients and the older clients, certainly always ask about cholesterol. It's always the number one quote, but isn't that all that fat bad for you? And for
Yeah.
example, my mother, who has been eating pretty high fat the last 10 years, she almost does what I sort of tell her to do, but she sneaks in a little cake
Right.
here and there, as they do when she's 80 years old this
Yeah.
summer.
Yeah.
But she doesn't take one medication, not one pill. She refuses to take, because when she was 50, maybe 51, they prescribed her statins.
Yeah.
Within a week, maybe less actually, she couldn't walk. She literally had to walk backwards. It was quite unreal to see.
Yeah.
So my dad was straight away, he was old school, throw them in the bin. It's them pills.
Yeah.
So she did. 2 days later, she was back to walking normal instead of walking like a crab.
Yeah.
So, I mean, fortunately for her, she had those severe muscle side effects because it was quite obvious what caused it. And she's never took anything like that since.
Yeah.
She's always getting bullied by the doctor. She just doesn't go anymore because they want your cholesterol's high. And now her friend, who is a very close friend of hers, that takes her out shopping the other day, my mum was buying Kerrygold butter, and she said, "What are you doing with that? You should be having, your Flora or whatever it's
Oh
called."
God.
I remember
Yeah.
that from the 70s, Flora. And she said, "Well, it's all right for your son because he's young, fit, and healthy." I mean, I'm not that young. I'm 53, so that's not that young. But it's all right for me, but my mum should avoid saturated fat. And so my mum's asking me, well, she said I shouldn't be eating that because the doctors told her that. So, of course, I just go on a rant. But then I said, I know who I'm going to ask. I'm talking to a professor.
Yeah.
What do I say to mum?
Well, first of all, congratulations getting your 80-year-old mum to do anything. My 80-year-old mum, I'm about the same age you are, Al, and so my mum's about the same age as your mum, and I can't get her to do anything she doesn't want to do, so there you go. All right, now let's deal with this, because I don't know how many times I've had to deal with this, and I don't know how many times I'll have to continue to deal with this, because this is not something that's going away. And the reason it's not going away is because there is so much money behind this. That, sadly, is the end of it. Because, yes, while there's money behind the idea that saturated fat and cholesterol are bad for your health in some way and that you should intervene with statin medications, the exact amount of science that is behind that is not one single scrap, not a jot. Cholesterol is a vital molecule in your body, and your body basically controls the level in your body. If you don't eat sufficient for what your body needs at that time, it will make it itself. Yes.
Yeah. Why would
if you
it make
consume exactly,
you?
why would it make something that's going to kill you, right? Because it's just ridiculous. If you eat too much or more than you need, you will excrete it.
Mm.
Your body tightly controls how much cholesterol is in your body at any given time. And that does vary from time to time according to your needs at that time. But your body knows exactly what it is doing.
You see, I'm not a professor. But I'm a logical thinker. And sometimes logical thinkers can think a little bit more logically.
Well, you'd think so, wouldn't you? That would be, yeah.
Exactly. But I've read many books on it because I've been doing this for 10 years now. I've probably read at least a dozen books on cholesterol. And probably my favorite one was Dr. Malcolm Kendrick's The Plot Thickens.
Yes.
A great book, and it all fully makes sense. And of course, the comeback that he had from that with almost losing his medical license tells you he was onto something. So my thinking was, and I've heard you say it, is the same amount of cholesterol, exactly the same cholesterol is in your veins as it's in your arteries.
Yes.
There's no plaque ever builds up in a vein. The end.
That's it. Yeah. I mean, at the end of the day, when I'm teaching, or when I used to teach this to classes of pre-med students and whatever else, instead of going through this theoretical biochemical model that's taught, they say this causes that, that causes the other thing, without ever supporting any of those interrelationships with any science at all. I was of the mind to say, let's build a deterministic model, meaning you look at something and you put that in a circle on the page, and then you have arrows going to there from any number of other circles of things that contribute to that factor. And the circle has to be completely explained absolutely by what's in the next level. And when you've got a logical break like the one that you've just given us, that's the end of the discussion. Okay. We are being told that this cholesterol in your blood will cause a problem, atherosclerosis, in your body, in the arteries of your body. And that, you know, the reason that this is happening is because of cholesterol, which ignores completely the thing that you've quite eloquently already said, which is, well, if cholesterol was causing a problem for endothelial cells in the vasculature, it would do it on both sides of the vascular circuit, the high pressure side and the low pressure side. It doesn't. End of discussion.
So they say, oh, it's because it has high blood pressure then. Oh, well, there you go. So it's not.
So it's not the cholesterol then, it's the blood pressure that we need to look at. Okay.
Yeah. And what raises blood pressure?
Well, insulin is one of the things that absolutely can. And what raises insulin? Well, that would be sugar.
Yeah.
And other carbohydrates that break down to sugar.
Yeah, exactly. So, you know, as a logical thinker, then my dad was a very logical thinker. He was like a gas engineer, and engineers tend to be more logical with that sort of thing. And he would just, if he heard that, he's not alive anymore, but he would just say, yeah, nonsense. Anyway, next. Because it would just move on from that. And that's how I think we get to that point now, because we've been talking about this for 10 years plus. And now, of course, they've almost renamed it. I loved watching you talk about, what's the doctor's name that was going over and over? I don't know, the guy that was involved with Epstein, allegedly, recently.
Attia?
Yeah, that was it. Yeah, that's his name. I forget his name, because he was very much into LDL as a risk and a cause. And you just destroyed that. And I loved watching that for the 2 hours that it was on. I think it was probably 3 hours, because you kept pausing it to shout at him. But but
that's kind of my bag.
Yeah, exactly. But so ApoB is like the new kid on the block. It's almost like they've renamed it to scare people again. So what is ApoB? That's another lipoprotein on the LDL.
Yes.
So it's particle size, which we've always said in keto that makes your particles big and fluffy, so don't worry about the big and fluffy ones. Does that still stand?
Okay. So what is ApoB? You'll notice they keep changing the goalpost, by the way. Cholesterol, first of all, it was saturated fat causes heart disease, they said. Then there were 5 major meta-analyses, all with multi-million person years of follow-up, all agreed, all were in line in terms of their output results. All of them said there is no relationship between the reported intake of saturated fat and heart disease. End of discussion. So they said, oh, well, it's not saturated fat, it's cholesterol, they said, which is usually, found alongside saturated fat. They go together, so it must be the cholesterol then. Only there is absolutely no causal evidence that that is the case, that cholesterol could possibly cause heart disease or would cause heart disease. We've already dealt with that one, because if it did, it would do it on both sides of the vascular tree. It doesn't. End of discussion on that. Oh, well, it's some subfraction of the lipoproteins themselves, because lipoproteins are the packets that carry the lipids around in the blood, because they won't dissolve in the blood plasma because that's water-based. So they need to have this protein package to put fats and lipids in so they can be transported around the body. That's what the lipoproteins are. And they come in high density, low density, intermediate density, and kylie microns, if you really want to know. But that's for another day. The different lipoproteins have a different tag, if you like, a different protein tag that identifies what they are so that your body knows what to do with them. Yeah. It's like putting an address on a package. If you want a package to get to a certain postcode, you've got to put the right postcode on the package, right? Yeah. Same deal. The lipoproteins, these specific ones, like Lp(a), ApoB100 is the one that they've been going on about a bit. ApoB causes heart disease now, specifically, etc. Okay, well, let's look at this logically. Once again, you need to understand that ApoB100 is a tag. It's a protein. It's a postcode that tells that package which tissue it will interact with to deliver that payload to that particular bed of cells. Yeah. That protein exists because of a length of DNA in your cells that tells your cells to make that protein. You, Elle, and me, believe it or not, and everybody else, we are all the peak of the biological process of evolution to this point. All at least 3,800 million years of it. And after that long, after 3,800 million years at least, our genes are so stupid, they are so inane, that there's an instruction in there to encode for a protein that's going to give us heart disease. That's how stupid evolution is. Yeah, it makes. I'm being sarcastic. Sense. Of course, it makes no sense. I know. It really makes no sense. And of course, as Dr. Kendrick points out, it's damage to the glycocalyx, yes, which apparently 95% of doctors don't know what that is. That's right. And on the endothelium, damage to that. So if it becomes damaged, then things can get in there, causing the blood clot, which the plaque is there to protect that blood clot, like a scab or hand. Yes. But of course, the scab falls off and your skin is better. If it fell off in your artery, you would have a stroke and die. So the plaque stays there. So the plaque's there to protect you. Yes, and the lipoproteins that deliver the packages of various different lipids around, including the cholesterol. You can think of the lipoproteins as the fire trucks. You can think of the lipids as the firemen that are doing the work of repairing the damage, putting out the fire. Blaming cholesterol or lipoproteins for heart disease is akin and is no better than the argument of turning on the television when there's a wildfire somewhere in the world, watching the trees burn, watching a bunch of fire crews scurrying around, and concluding, therefore, the cause of the fire was the fire crews. Because they're always there. That's right. Therefore, they must be the cause. And apparently, it's not actually the same cholesterol that's in the plaque, isn't it? Cholesterol crystals are. Oh, look, until you get very, very advanced unstable plaques, there's almost no cholesterol present in a plaque. No. This idea that they say cholesterol-laden plaques and cholesterol clogging up your arteries, absolute nonsense. The stuff that's clogging up the arteries is the plaques themselves, and they are consisting almost entirely of clotting factors and scar tissue.
So it's a scab, basically.
Basically, it's a scab. Yeah.
Yeah. And what causes the damage to the endothelium, as of course we know, smoking, used to be car fumes, lead, and as Dr. Kendrick said, somebody with sickle cell disease, their chance of heart disease goes up by 50,000 times, he said in his book, because of the red blood cells are shaped like a sickle. So it's causing damage to the endothelium all the time.
Right.
Because then children get heart disease, which of course in normal blood, that doesn't happen.
Yeah.
It's out. So that makes logical sense.
The other thing that's very interesting to note is that not only do atherosclerotic lesions only occur in arteries and never in veins, but they don't occur evenly in arteries either. They occur in specific, predictable sites. If I want to go into a body and find atherosclerosis, and I have done this more than once, I can either, in a living person, I can use scanning techniques. I know where to look. I can go straight to it. This is where, if there's going to be atherosclerosis, this is where it's going to be, and go straight there and find it there. And if we're talking about a person that's deceased, we can cut them open and go straight to where it is and say, look, there it is. We knew it would be there. We didn't have to go looking.
And where would that be?
Well, the sites that atherosclerotic lesions occur are in the largest of the high pressure side, the arteries, not the smaller ones, the largest ones, where the pressure pulsatility is the highest, where the pressure on those walls is the highest, and not just everywhere in the biggest ones either. You can break it down still further and say it only occurs where you get a bifurcation, a Y shape, or you've got a curve like the aorta.
Yeah.
So what you've got when you've got blood going around an aorta or out through a Y, you've got turbulent flow.
Right. So it's like a current.
Right. So exactly. So you've got this laminar current, or pulsatile currents, I should say, not laminar, it's pulsatile because the pressure's doing that.
Yeah.
And every time your heart beats, some of the blood circulates around in eddy currents and turbulent flows in various areas. That's where the lesions occur, where the blood's doing this circulating around in an eddy current. Why? Because the transit time of that blood across that area of endothelial cell bed is extended. It's a longer period of time because of the eddying around. Ergo, that pulsatile pressure is being exerted against, and the shear pressure as well, against that cell bed for a longer period of time, and that is physically damaging those cells. You add to that cigarette smoking, in the past lead fumes from petrol, poor dietary habits like glycating the hell out of yourself,
and higher blood pressure. So
higher blood pressure leads to more turbulence, leads to more disease.
Times, or is it 7 times more than veins, the blood pressure in an artery?
The mean arterial pressure is
a lot higher.
It's 2/3 of the, like, there's a sum that you use that you work out the mean arterial pressure. But I mean, the pressure is vastly higher.
Yeah, and then someone with high blood pressure, it's even
vastly higher than that. Exactly. Yeah.
Exactly. So lower the blood pressure, lose the weight, quit smoking, and
stop eating carbohydrates,
and lower the insulin, and then you're going to be a lot better. So basically, I need to say to my mum, just carry on with your Kerrygold butter and go shopping on your own.
Yeah. And also, basically, you might suggest that your mum, if she isn't already, should undertake 5 health hacks. The same 5 health hacks that everyone should undertake, I believe. And it's what I base my practice on. It's what I tell my clients. And, you know, it has a 95+% success rate in terms of people being able to resolve whatever symptomology of chronic disease they have based on Western life. And if you want to know what those 5 health hacks are, there's a video on my channel, on my YouTube channel, called 5 Health Hacks. Okay. You need to know. which people can watch. It's like a 20-minute video, so it's not too hard to get through.
Yeah, I'll get to watch, see how many she's already doing, because I've been trying to hack her health, and I say she's pretty good for not taking any medication, and she turns
look, in terms of statins, Al, it's very simple. Statins, contraindicated metabolic toxin. No human being alive under any circumstances, in my opinion, should touch statin drugs with a barge pole. They can kill you. And,
I'm friends with Dr. Asim Malhotra, and of course, he wrote a controversial book back in 2012, A Statin-Free Life, which, of course, he had years of backlash and lost lots of work, no doubt, for writing that book. But he said that 5 years on a statin, you will potentially extend your life by 1 day.
Maybe.
That's if you can walk.
The other thing that happens at the same time as that, though, is that per person year of statins at a moderate dose, the incidence of ALS, which is a universally fatal neurodegenerative disease, the incidence of that disease, it's the one that killed Stephen Hawking.
Oh, right, yeah.
That goes up in statin-taking populations by, get this, 18,500% in at least one reasonably sized study.
Oh, wow. So that, it's not really worth risking it for that 1 day.
For one potential day, which you're not even guaranteed to get. Of course, you're not guaranteed to get ALS on the flip side.
That's obviously not from the lowering the cholesterol. That's from the anti-inflammatory things of the statins, because they do lower inflammation. But lower inflammation with your diet rather than a drug.
That's right. The statin-induced lowered inflammation is a short-term lowering of inflammation. Once a person's been on a statin for some time, that situation will reverse, turn around, and the inflammation will be much, much worse for that person. So you're absolutely right. In the short term, they are anti-inflammatory. Yes.
And for some people, obviously, what happened to my mum? Because she literally couldn't walk. So it would have been,
it would have been rhabdomyolysis and or electron transport chain issues. But when I said that statins are a dangerous metabolic toxin, the reason I said that is because the mechanism of action of the statin medication, it doesn't just knock down cholesterol. It knocks down the production of a bunch of other things in the same metabolic pathway. It just like scattergun just knocks it all out. And exactly that. Yes, you got it out. It's coenzyme Q10 that gets knocked down. And for those that don't know, coenzyme Q10 is one of the respiratory chain pigments. It's one of the most important energy transfer agents in the mitochondria. And if you knock down its ability to do its work, those cells can struggle.
And once you have no ATP, you die.
That's it. Well, if a muscle cell gets low in it, it's going to shut down. So you're not going to be able to use that muscle. And you'll find that muscles are quite useful for things like walking.
Yeah,
the other thing you'll find is that your heart is a muscle. The very thing that statins are supposed to protect may well actually eventually be stopped by a statin, because you might actually poison yourself with the statin to such a degree that that heart can no longer function.
Wow. But when there's $1 trillion
that's right. Safe and effective, Al. Safe and effective. Don't question the science.
Yeah.
Whatever you do, just say safe and effective and be belligerent about it. And say statins save lives, even though they don't. Just say that they do. And
thank goodness we have somebody with your knowledge and credentials to back up what this meathead is telling people.
Yeah, exactly.
So that's it. So I've got a couple of questions from my group, if I may.
Of course.
I have a little group going. And again, some are quite into nerdy stuff and some are into meathead stuff. And I'm sort of there stuck in the middle. I'm a bit of both.
Right.
I'm a nerdy meathead.
Yeah. So. Tommy two ways, is that what you're saying?
Not quite.
All right.
Only at weekends.
All right, very good.
So what is the role of the inner mitochondrial membrane, specifically cardiolipin, in energy production and electron transport?
Right. Yes. Okay. So in your cells, in every one of your cells, for want of a better term, the battery packs, they call them, or the energy providers for cells, are thought of by the mainstream as being the mitochondria. Mitochondria evolved as separate living bacteria way, way back in time. And very, very early in the development of multicellular animals, these particular bacteria that are now known as mitochondria decided to live inside the cells of other bacteria, safe environment, food provision, why wouldn't you? And it was this partnership that allowed for the development of multicellular organisms by the virtue of the fact that mitochondria were able to react carbon skeletons with oxygen to provide energy. And it's a long, convoluted process, of course. But the design at the end of the day that we've ended up with the mitochondria is that they are like mini cells of their own accord. They have their own RNA, DNA molecule inside to encode for their own carry-on. Right. They have two membranes, an outer and an inner. And the reason for that is because the way that energy, so-called, is produced is that hydrogen atoms are split in such a way as that electrons are held on one side of the membrane and the rest is held on the other side of the membrane, thus providing for a proton gradient, if you like, or an electron gradient is more to the point, which can then be used as a source of potential energy. And then you allow the electrons and the rest of the hydrogen to recombine with the oxygen to form H2O, water. That releases the stored potential energy, and that's encapsulated in another way by adding a inorganic phosphate group to another molecule, which is called adenosine diphosphate, and that produces adenosine triphosphate, which I'm sure everybody knows is ATP.
Yeah.
Right. The workings of that inner membrane involve the protein that you're talking about there, the pectin stuff, cardiopectin. And it's involved in the structural integrity of that membrane, and it assists in the formation and workings of the various electron receptors in the electron transport chain that progressively encapsulate the energy as the electrons are dropped from a high energy level down to the lowest energy level, which eventually is the combination with the oxygen. There are a number of different respiratory chain complexes that are inbuilt into that membrane, and that's how it works, basically. It's a physical barrier that keeps the electromagnetically charged components.
Pretty important.
Yeah, so that's the role of it, basically. That's what it does.
So how does a high linoleic acid intake affect the composition and stability of the cardiolipin in that membrane?
Well, this is not a slam dunk, and there's not a lot of science that we can point to in situ in living human beings. All the work that I'm aware of any quality has been done in vitro, in a lab, in isolated cell cultures and things. So it has to be taken with a grain of salt in that way. But the idea is that if you've got fat molecules that are either of the wrong chain length or that are vulnerable to oxidative and or glycative damage, thus conformationally changing the shapes of those fatty acid chains, those fatty acids will no longer fit well in a phospholipid bilayer, i.e. a membrane. That membrane will be leaky. It won't seal properly. It won't keep water on one side, fats on the other, as it should do. Things are able to leak through there, and you get a whole cascade of problems from there. So,
So what's the downstream consequences of mitochondrial efficiency and electron leakage? Then, of course, it must get worse. So you start less energy.
Well, I mean, alpha-linoleic acid, ALA, is obviously omega-3.
Yeah.
Once it's been, correctly formed for use in the mammalian system. And it's best to get your omega-3 from already formed animal sources. The human ability to synthesize it from the base molecule, the plant-based molecule, very, very poor indeed. So if you want a decent amount of omega-3 in your diet, you really ought to get it from animal sources. And you don't need to eat seafood, by the way. There is an amount of omega-3 in ruminant muscle meat. A very small amount, sure, but luckily a very small amount is the amount you need. A very small amount is optimal in terms of performance of various things. Too little is a problem, and too much is often a problem.
So would you recommend someone takes cod liver oil, for example, or fish oil?
I wouldn't, and I'll tell you why. Because when you extract and concentrate omega-3 rich oils and put them in bottles, that's usually done in factories, under pressure and under heat. Those oils are very, very susceptible to the oxidative side of the damage, thus conformationally changing them into slightly different molecules, like, for example, aldehydes.
Yeah. So they're already rancid.
Exactly. They're rancid. Even good quality, good brands, you buy an omega-3 supplement, you are almost certainly buying a rancid oil. And if it contains significant amounts of aldehydes, well, aldehydes are vastly toxic to cell membranes, to organelle function, to mitochondrial function, to life in general. They tend to mess with things like DNA. They're absolutely toxic at very, very low levels. So I would not touch an omega-3 supplement. I would make sure that I get my omega-3 in very small amounts, which is all I need, from eating red muscle meat.
Yeah, and my diet, say I do keto, but it's probably 80% animal protein and fat with a little bit of salad thrown in.
Right.
As you know, we've probably discussed before, I do a cyclical keto, and that's changed over the last 8 years from 2 full days to 2 meals to 1 meal. I've played around with it and to see where I feel best, to see where I also look best, because of course when you're a physique athlete, there is a certain look that me and the clients want to achieve. To try and win that show. And I've done bodybuilding show without any carbs. I was there eating my anchovies and salt backstage.
I bet that was popular.
No, exactly. Not smelling as fresh as the donut eaters, but I still won. So, but I felt a little flatter. I don't think you can get as full as when you eat a bunch of rice, but I am very, very strict with my refeed, as I call it, and only white rice. And it's down to about 2 meals, 2 portions of white rice. As you know, the wife is Chinese, which does help with our social events. And her mum owns a sushi restaurant, for example. It helps. Yeah. So that helps. And it also helps clients to make it sustainable, because if you tell them, you don't need any carbs ever again, you're not having any more, then people are scared straight away because they're addicted. Of course, it's like telling somebody you can't have it, they want it. But once you broke that sugar addiction, then the white rice tends to be less of a problem compared to desserts, which of course is fat and sugar. All cakes and cookies, it's all fat and sugar. Whereas
white sugar is much worse than sugar by itself.
Yeah, exactly. Because of course, white rice, we're going to use it and burn it off in the gym. It's going into the muscle. How does that sit with you, what I do in that way?
I know that hypertrophy-based athletes, bodybuilders, that whole side of the industry, I know that they believe fully in the need to have some carbohydrate, if nothing else, for appearance. It plumps up the muscle. It helps with the storage of water, as does creatine, which makes the muscle look more plump. It makes, et cetera, et cetera, et cetera. There is an argument that the performance in the gym and training is better with carbs, which is true only in the case of a person who's not fat adapted. You take someone who is carb adapted, who's a carb athlete who eats carbs every day and relies on carbs for performance, and you put them in the gym the day after suddenly changing their diet and taking all the carbs out and saying, you're going to have to run on fat, well, the performance will tank. Of course it will.
Yeah.
Because they need time to adjust. An athlete that is fully fat adapted, that's not a problem. They perform as well, if not better. There are plenty of bodybuilders that do not carb up and do not feel the need to carb up, either in training or for competition day. I'm not adverse to what a person wants to do. If a person wants to have carbs in their life, for whatever reason, I'm not going to sit in judgment on that.
Yeah, of course.
I'm in no position to sit in judgment. I eat carbs myself from time to time. I know. Ted says I should hand my card in, don't you, Ted? Yes. You go and do your thing, Ted. Good boy.
But you see, like when I trained, probably the hardest 4 days of ever training with Dorian Yates to get certified by him. Yeah. And of course, he pushes you like nobody else. And when you're with someone like that, you train harder than you've ever trained before. Yeah. I never had any carbs over the 4 days.
Good.
Nothing. I just had a lot of salt and a lot of water because it was like 45 degrees in this gym with no aircon. So we need the electrolytes. Right. And I always take about a spoon of salt, half a spoon of salt before the workout. Anyway, including my electrolytes. I have that extra to increase the blood volume and just the feel. You have a better workout, you have better pumps, and my veins are popping out and there's no carbs. But of course, I've done the cyclical now for 8 years and I've tried. I'm very fat adapted because I've done 1,000 grams of carbs, 500 on the Saturday, 500 on Sunday. Monday morning, I was 0.5 on the ketone blood monitor as soon as I woke up. So there was obviously not causing me any issue in that way. But before, when I was a carb addict, if you like, I was pre-diabetic and I was always tired and I was always had indigestion and always had aches and pains. And now I don't have any of that. And I'm 10 years older. So in theory, it should have got worse.
Yeah. So, to summarize, if a person wants that in their life and they feel like they need them and they feel like they can't do well without the carbs, well, it's no skin off my nose. It's your funeral. I'm not going to sit in judgment. As I say, I'm not going to judge you. But what I am going to tell you, anyone that's listening, is the exact requirement on a day-by-day basis for carbohydrates in a human being, even an athlete, even a high-performance athlete, high-intensity athlete, even a bodybuilder, makes no difference. The exact requirement for carbohydrates on any given day is exactly the same, and it's none. Not 1 single gram. 0.
Yeah. No, and I've obviously heard you say that many times, and I do not disagree at all. And I'm not trying to push hundreds and hundreds of grams of intra-workout carbs and stuff. My clients are generally having a portion of rice on a Saturday night because they're going for a Thai meal or something. It's compared to what they was eating before, it's practically 0 because they would have more than that by a Monday morning at 8 o'clock. And they all feel better, and so if it makes it sustainable, if it makes them stay on it,
exactly,
so be it. Perfect. Another couple of questions if we've got time. I don't want to keep you.
No, absolutely. Go for your life.
From your farm,
right?
As they say. So, what are you doing on the farm now? Growing your own Animals?
Yeah, we have sheep, we have beef, we have goats for dairy. We have chickens and ducks, both for eggs and for poultry meat. My sister is here living with us with two of my nieces and an adult nephew, and they all live and work here, and they're not carnivores. So my sister's loving it. She's, she can grow a garden and can grow pumpkins and marrows and tomatoes and all that kind of bullshit. So that we're doing that.
Do you eat much vegetables yourself or never?
Well, since my sister's been here, I have been. Let's be honest. At the end of the day, she arrived a few months ago and started making all the stuff that, we used to have as kids and that Mum used to make, of course, because that's what happens. And I'm like, I guess just this once, just today, I can have some of that because it's been ages since I've had that. And that's turned into 2 months of every day doing, just today.
But no doubt it's organic.
It is, absolutely, and it's good in that regard. But nonetheless, I've put on 7 to 10 pounds, to use the old money, in a couple of months. My energy's dropped. My skin's turned to shit. My joints hurt. It's almost like these plants are fucking against me here.
Trying to kill you.
Yeah.
And
it's almost like they are.
Do you think there's a specific one that's worse than the others, or
for me,
nightshades?
For me, it seems that my biggest issues are around gluten and probably just overtly, a lot of glucose in the bloodstream, leading to that sort of inflammatory state, assisted along by the gluten response
compared to what you was before.
That's right. Because I was relatively clean for a decade.
Yeah.
But anyway, we'll get back to it. I mean, it's just a readjustment, and
you get bored of it.
Yeah.
What is your thinking on when you mentioned dairy? Because I know I've been chatting to Dr. Sarah Myhill. She's going to speak at my upcoming retreat, and of course I love her attitude, her work, and her young brain that she has, and she's pushing 70 herself, but you would never know talking to her. Sharp as a tack, as they say in England. But she also obviously recommends the PK diet, she calls it, the paleo ketogenic diet. So basically keto without dairy, because a lot of people are allergic or sensitive to dairy. And is that because of the crap that's in the dairy these days? If you've got your own cows or whatever, then, which nobody has, let's face it.
Okay. As a kid, I clearly had lactose intolerance issues, or classically what is usually described as lactose intolerance issues. As such, we avoided cow's milk for me throughout my formative years once we worked out that was an issue. I have not had an issue with raw goat's milk.
Right.
Or raw sheep's milk. So whether it's the difference between cow's milk and sheep and goats, or whether it's the difference between what you get in the store, which is pasteurized, because you can't have non-pasteurized cow's milk sold in New Zealand. You can't do that. So, is it because it's having goat and sheep and not cow? Or is it because it's raw and not pasteurized? I don't know, but that's not a problem for me. Whereas the other was. It's an individual thing. Your mileage will vary.
You see, when I started reading her books and talking to her, I quit the dairy for a week or two. And I eat a lot of dairy because being in Sweden, it's a very dairy-centric country here. There's bigger dairy sections than there is sweet sections, which is nice. And I eat the dairy. But I noticed once I come off, my hunger level went down. The dairy, I noticed, makes me hungrier. And I lost a couple of pounds, which I didn't want to do. So I went back on the dairy because I do really enjoy it. I don't find anything negative stomach-wise, energy-wise. But when it comes, if I was dieting for a show, I think I would remove it now because I was less hungry not eating the dairy. Maybe because the lactose that's in it, the sugar, the spikes it was causing me, a little insulin spike created some more hunger there. But I guess somebody, if they're sensitive, remove it.
Is that exactly it? It's very individual. I've always said to people, look, you do what works for you. If you feel like any kind of dairy is great and is awesome and you swear by it and you don't have any obvious negative response to that, either in terms of reactions or body composition problems or energy problems, shall we say, then, you fire ahead, you do that. That's fine. And if you do have a problem with it, or if you suspect that you have a problem with it, remove it for several weeks and see if the problem resolves. If so, that's probably your answer. Then you'd add it back in to absolutely establish that, and then the problem would return and you'd go, yep, that was what the problem was, like an elimination. Yeah. So that's fine. I don't have a problem with that. I mean, people that want to run around saying people that take dairy are not real carnivores, get a life.
Yeah.
Honestly. Goodness. I didn't know that you were in Sweden. How long have you been there?
Since COVID came, since it was allowed to fly, they didn't close the gyms in Sweden. So,
or anything else,
a good idea to move. And the missus is Swedish, so
Swedish Chinese.
Chinese born in Sweden. So
there you go.
It was an excuse to move with Brexit, etc. Everything happened in it in 2020, and it was a fantastic. I'm still between the two places, of course, because I've got a lot of connections in London. But
in that London.
Yeah, I'm not actually from London. I'm from the Midlands.
Your accent is definitely not home counties. No,
it's a weird accent because I lived in London for 25 years. My accent from the north or Birmingham area, Midlands, has changed. I'm Derbyshire, so we call everybody duck. Hey, me duck. Hey, me duck. That's how we, which is a bit odd. So you go to London, you've got to stop calling people duck. Because they don't know what you mean.
Yeah.
Okay,
no, you're from up north. That's what they say. You're from up north, aren't you?
That's what Londoners say, but they've never been past the Watford Gap, as they say.
Right.
So that's about 20 miles north.
Yeah.
So a couple more, if I may.
Yeah.
Oh,
absolutely.
One thing I said I would ask you, and I didn't mention this before. A client of mine has suffered with lipomas, I believe they're called. These lumps on the skin.
Yeah.
And of course, I've got him on the ketogenic diet, removing all seed oils. And if anything, they've improved.
Yes.
It's still there, but he's only been on this diet for approximately 6 months. And I said seed oil can take 2 to 3 to 4 years to come out of the cells. Don't they have a half-life? Like almost
they do, yes.
Days?
Yeah.
So do you think that the inflammation from the poor diet before, he's in America, so of course the diet is super toxic. Could that, I think it's always diet, these skin issues, personally.
Yeah. Well, I think absolutely. If a person sorts their diet out, that's a large portion of the battle in terms of most problems that you'll find a person presenting with from Western society. There are, however, 4 other health hacks that I would add to the diet. So there you go. I've given you number 1. The correct diet is the number 1 and the most important of the 5 health hacks. Absolutely.
Yeah.
There are 4 other things I would add to a person, any given person's regimen. That person having come to me and said, look, I've got this problem X, Y, or Z. There are very few conditions that I'm presented with that I go, you know what, my 5 health hacks is not going to fix this.
Yeah.
So it's kind of like a mantra. It's like, it's almost like, well, you're absolutely individualized advice. Not that I give advice, I give opinions. But my opinion is the 5 health hacks will help you too, yes, if you have lipomas.
Right. So
over time, not straight away, not overnight. Yes, this is a process, but it absolutely will help.
And Dr. Sarah has health hacks, as she calls, and they're all reasonably cheap as well, because she calls her clients BBs, the broke bastards, because they've got
they're all broke.
They've got chronic fatigue, so they can't work. So she has her protocols as cheap as possible. So things like high dose vitamin C and iodine being two of the things that she adds for her thyroid support, I guess, and antibacterial support from vitamin C. What do you think to those two?
Vitamin C is one of those things that the recommended daily intake of is vastly higher than is indicated. A lot of people don't understand that the RDA for all sorts of things, RDI or /RDA, whatever it's called in various different territories, the recommended intake per day of various things. None of those things are based on experimental science. They are numbers that are arbitrarily applied.
They just made it up.
Pretty much on the basis of how much of this do we think a person needs, add in a safety margin, even though that might actually be the exact opposite, unsafe in some cases, but let's do it anyway. Throw that number at it and, jobs are good in, sort of thing. The issue with vitamin C is that, yes, a person eating a standard Western or standard American diet, including a bunch of carbohydrates, etc., that person will need more vitamin C in their diet than a person who eats a species-appropriate, species-specific, 100% carnivore diet.
Got you.
Because the major transporter for vitamin C is GLUT4.
Right.
So if you're eating a bunch of carbs and those carbs are gumming up your GLUT4 all the time, the concentration of carbs is vastly higher than that of vitamin C. It's going to outcompete the vitamin C. So you need a higher level of vitamin C so that vitamin C can get a look in because they share a transporter.
So if you're carnivore, you need less.
Much less, like nanograms per deciliter in your blood, which luckily is exactly how much you'll find in red meat, pretty much. It's almost as if we evolved that way. No, that's crazy talk.
So the cavemen wasn't taking vitamin C pills, basically.
No, they weren't. Neither were they looking up the tables of RDIs for anything.
No.
You won't also see pictures on the walls of caves of ancient humans standing around sharing a salad.
I think we've covered every single question on there, except for one, but I know the answer of that because I haven't read through all these as well.
All right.
Dude, you'll like this one.
Go on in.
Not a lot. Do high carbohydrate intake and high linoleic acid intake together amplify oxidative stress beyond what the system can handle? I think we know the answer to that.
Yeah, I think, look, absolutely. The likelihood of that is probably elevated. We need to be very careful about making absolute statements, cause and effect statements, because we don't have the science to underpin that. Anecdotally, it looks like it's pretty likely that you add those things together and you might well be looking for a problem. As such, I wouldn't do it. Well, this is exactly the thing. The Randall cycle, we can cover that if you like. The Randall cycle, ostensibly, for those who have never heard me talk about the Randall cycle or anybody else, I can boil it down pretty simply these days. Think of your oxidation of carbon skeletons for ATP that we described earlier. Think about that as if it's a train trundling down a track. And if the train is going left to right, what it's doing is it's oxidizing a bunch of carbohydrates for energy, and that's what's causing the momentum of that train to go left to right.
Yeah.
If you want, instead of oxidizing carbohydrates for ATP, if you want to oxidize fats for ATP, you've got to bring that train to a halt.
Right.
There is a lot of inertia in a train. It's a big, heavy thing. It takes a lot of energy to get it moving, and it takes a lot of energy to stop it once it is moving.
Yeah. It's under momentum. It's keeping
momentum, inertia, resistance to change in momentum. Yes, all of that. The same deal applies to your metabolic pathway. While it's not a train, that's just an analogy, what it does have, though, is a lot of metabolic inertia. It takes a long time to switch it from one source to the other, relatively, and a lot of force is required to do it. Why is that? Well, fats and carbohydrates cross-inhibit one another from entering the Krebs cycle, otherwise known as the TCA cycle or the tricarboxylic acid cycle. Why is that? It's because both fats and carbohydrates are broken down in the first instance for entry into that cycle to acetyl coenzyme A. So if you've got two competitive sources of acetyl coenzyme A, both trying to get through the same bottleneck, you've got a problem. It's like two fat men trying to go through a revolving door at once.
Yeah. So it's going to prioritize the one that it uses.
That's right. So what any given mitochondria has been doing for the last few minutes will be what it will continue to do until a force powerful enough to cause it to do something else is applied. Newtonian physics, if you like.
So when I do my carb day on a Saturday, for example, I don't have fat that day.
Right.
So I switch to that because there is no fat. And so I tested my blood on the Monday morning and I'm back into ketosis because then I'm back onto high fat.
Yeah.
So of course that's either or. It's not competing.
It sounds like you're well adapted and you have the metabolic flexibility to switch backwards and forwards because of that. Your average Joe is going to struggle with that because when you think about your average Joe, how long does it take somebody from their normal carved up diet to a position where they can actually get the purple on that stick?
Yeah.
It's about 3 days, isn't it?
Days, yeah.
About 72 hours to get into ketosis. Whereas, Al, it sounds like you can switch backwards and forwards pretty much overnight.
Like a child can.
Yeah, if you like. Most people can't do that. And here's the problem. If you've got fats in your bloodstream trying to enter into your cells to enter into the pathway, and you've got carbohydrates in the form of sugars trying to push through there, you've got that acetyl coenzyme A bottleneck, you've got one cross-inhibiting the other, two fat men trying to get through the door at the same time. What actually happens is while you've got an excess of energy in two different forms, the energy actually getting through to the mitochondria is reduced, right? Because it can't get through. It's
whilst they're fighting.
Therefore, the energy level, the redox level in that cell drops slightly. The level of ATP is going to drop slightly. The level of ADP plus PI is going to increase slightly. And PI is inorganic phosphate, the very thing that binds to all the pro-inflammatory cytokines. So if you're running on fats and carbohydrates or are trying to, what you're actually imposing is chronic systemic inflammation.
Which
necessarily
has got.
Right. Ergo, here's what you should never do. You should never consume a diet which is mixed in terms of fats and carbohydrates. Choose a diet that's rich in one and very, very poor in the other. But before you do that decision, have a look at those two diets, the fat-rich diet and the carbohydrate-rich diet, and decide which of those diets provides all the nutrients necessary for human health and longevity, and which one of those diets is absolutely destitute in terms of that. One of those diets lacks no less than 13 required nutrients for a human being.
And I've done both because of being bodybuilder. You're eating chicken breast and rice with very low fat. And yes, you can get big, but you don't look healthy in your skin, your face.
You're not healthy.
And you're not healthy because, of course, you just feel inflamed, headaches and pains and all sorts. But I'd much prefer the keto days. It's just a tool. And I can't wait to get back on my butter. That's my that's my
I love butter. It's good
that's
stuff.
my fat. I bought one today. It was like this big, like I don't know how big, 1.5 kilos of butter.
Right.
So I eat slices of it.
Yeah, good. All right, well, there you go. So that's the Randall cycle in a nutshell as well. Why does it exist?
You explained that the best I've heard this time, and it's quite clear that is activated when one's trying to get in that the name's not down on the list, basically. You're not coming.
That's right.
But once we've been running on fat for some time and then carbs comes along, would that kick the carb out then?
Exactly. Fat bumps carb out of the way if there's enough of it. And carb bumps fat out of the way if there's enough of it.
Until it's been so long, and then if you're doing a mixture of the two, would it then, if I started going fat and carbs now, a standard diet, how long would I be burning fat for as a full? Not very long. It would then switch to carbohydrate.
It depends on the exact makeup of the macronutrient split. It depends on what's being exposed to which cells at what time in your blood. It depends on your individual genetic makeup and the environment in which you place those genes at any given time. It's a rich tapestry, Al.
Right.
Your mileage will vary a lot. The concept holds that fats tend to inhibit carbs and carbs tend to inhibit fats. If you've got any meaningful mixture of both, you're going to have an inflammatory response to that. And if you are chronically doing that 3 and 4 times a day, every meal of your life, you are inflamed all the time. And we know that chronic inflammation is going to lead to all sorts of other sequelae, don't we?
So again, the Randall cycle is then another protection mechanism in the body.
Well, the reason it exists is precisely in order to prevent the vastly complex, intricate, important cells of your body, like muscle cells, is to prevent those muscle cells from being damaged by an overplus of sugar entering. The mechanism by which it works is that when there is a lot of fat, sufficient fat to run the cells, they don't need any carbohydrates for energy. What happens is, you know those old style locks that you used to put those cast keys into and you'd turn it and you're right, and you could put a key in the back side of that door to prevent someone from opening it from the other side? That's exactly what's happening in the cell, in the Randall cycle being activated by a lot of fat. The key is being put in the back of the GLUT4 transporter. So it doesn't matter how much insulin you apply, the key to the outside, you can't turn that lock. Those cells are saying, we are full of energy laden substrate. Thank you. We don't want any sugar in here, because if you let the sugar pour in on top of that, what's going to happen is you're going to glycate the hell out of your cells.
Yeah.
So what your body does is it says, okay, the sacrificial lambs are the red cells, the white cells, formed elements in the blood, and the endothelial cells. We're back full circle to atherosclerosis, aren't we?
Yeah. Again, you've just egged me on to our, hopefully, another call with you next time, all about glycation. I've been studying that lately, and I've got a talk myself for my retreat all about glycation. And I believe that is one of the drivers of all disease.
Yep.
And heart disease is the glycation of these cells. And of course, that comes from sugar.
Glycation, oxidation, physical damage due to the blood pressure issues and turbulent blood flow that we spoke about earlier.
And of course, fructose is 10 times more glycating.
Yes.
So then we could segue into Paul Saladino's maple syrup diet.
Paul Salad, I don't know.
Yeah. So that must be high in fructose, which is glycating the hell out of those cells.
Well, take a look at a picture or an image of Paul Saladino taken even 5 years ago and put it next to one taken this week.
Yeah.
And tell me the boy hasn't aged 15 years and 5.
Yeah.
And it ain't because he's been in the sun.
No, I'm in the sun and I don't do fructose and I'm going backwards. So that's my plan.
There you go.
So I avoid that. Okay, Bart, it's been a real fantastic pleasure and real nice catching up with you again. So
likewise, always a pleasure.
We'd love to do it again when you're free.
Absolutely.
Perfect, mate. Thank you very much. Thanks, mate. Pleasure. Thanks, mate.